project Physics of Impact talks mainly about the acceleration, position, and velocity and impact. Home Group 1 is going to go over two different videos that were recorded. In the first and second video, you can see Eric throwing an apple in the air and smashing it with force. This covers acceleration and very low impact. The mere stick measures 2 units in the air, and on the ground the speed of the apple coming down is going to be far greater than if it were in the air. This is because Earth's gravity is pulling the apple down double the speed than if it were going up. You ask why? This is because Earth's gravity is stronger in force and acceleration. As for the impact before the apple was smashed, Eric applied additional force to create a greater acceleration and impact. Putting these two factors together, we get an apple explosion. In the third and fourth, you can see Eric tossing a ping pong ball in the air. After this, Eric slams a water bottle at a certain distance and angle. Bits and parts of the video cover impact and positions and the net force formula we use. Triangle V equals final velocity and initial velocity, and A equals final velocity minus initial velocity divided by time. As I said before, you can see Eric tossing a plastic water bottle at a certain angle, so when upon impact, it will explode. With our research, we discovered that with enough force and in the right position, you can calculate the time before the impact and see a pretty cool explosion of yellow residue. The ping pong ball dropping and the apple dropping at different times and different weights, they will drop at the same time. As we conclude our presentation, we'd like to take a moment and explain the fun moments we had, and at the end of our showcase, we have some bloopers. In all honesty, we all had a great time and we had some lessons, but we are also academically prepared for this project. We were happy that we got to spend time with each other and actually work as a team. I'm proud of Home Group 1. Now we made some bloopers for academic purposes. We hope you enjoy.
Hey, what are the net forces involved with the activity? What is net force? The forces involved with this activity are the push and hand in order to get it into the air. Gravity is also involved, in which it pulls the paper ball back down the ground. A net force is the net magnitude and direction of all force vectors added. The net force in our activity must be greater than the pull of the gravity, which force goes down on, since the ball moves diagonally upward in order to not be pulled down immediately. Acceleration is a vector quantity. This is question B, by the way. Acceleration is a vector quantity that is defined as the rate and change in which an object changes its velocity. X and Y components being independent, the net force influences our ball when it's greater than gravity, because the greater the net forces, the greater the acceleration. Being straightforwardly corresponding to the extent of the net force in a similar bearing as the net force, and contrarily relative to the mass of the object. Also influencing how vertical and horizontal acceleration in our activity is increasing, whilst the vertical acceleration is decreasing in our net force increases. And horizontal and vertical velocity. Velocity is a vector quantity that refers to the rate at which an object changes its position. Velocity is influenced by the net force by creating acceleration that then changes the object's velocity. In our activity, the net force affected our object's vertical and horizontal velocity, in which it caused it to go down. Horizontal and vertical position. Positions is the area or location of an item, whether it's an individual, a ball, or a molecule at a given moment in time. The net force influences the position of the object. That, in this case, is our paper ball. By further moving it upward into the air and away from the ground until gravity, being the force that draws on a body towards the focal point of the Earth, or towards some other actual body having mass, eventually pulls it down for the ball to impact the ground. As shown within our video, the ball reaches its highest as it followed the horizontal and vertical axis, also moving slightly higher than moving downward along both. And that's it.
The forces involved with the activity are weight, drag, and lift. The net force at the top of the toss is 0. For the first position of the velocity of the ball is going slightly up and going to the left. The second position of the ball is going a little less up while it goes less to the left. And the third position is where it starts to go down and goes to the left more. For the fourth position, it starts to decrease a lot more. As it moves to the left, it decreases as well. For the fifth and sixth position, they both seem to be decreased in the same direction. And for the final position, it has lost most of its force as it hits the ground.
The activity we chose to analyze is the physics of a punch. We chose this activity because I'm into MMA and I take MMA classes. There is many reasons why I like doing this activity, but to keep it simple, I just like fighting. Some forces involved with our video of me punching Henry are the strength of my punch, gravity, and air resistance. My punch was strong enough to overcome air resistance and gravity. The net force is the three forces acting upon each other. These forces cause Henry to move back, and acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity. The horizontal acceleration increases until my punch hits Henry. When the contact is made, my fist stops, so acceleration greatly decreases. On the y-axis, the acceleration slowly decreases in the first 4 points, and on the 5th point, it increases. Velocity is a vector measurement of the rate and direction of motion. The net force influences the velocity horizontally because it increases after each point. On the y-axis, it slowly decreases after each point. Position is a place where someone or something is. Position increases horizontally, and on the y-axis, it slowly decreases after each point.
The forces being shown in the video are the Earth's gravity and the air's force against the ball, also known as gravitational and air resistance. These are being shown when the ball is thrown up into the air and when it comes down from its highest point. The net force is shown in the video by the arrows that are always acting against due to the acceleration, which is being affected by gravitational pull. And so the ball is going downward, so the ball's velocity is slowly moving to the negative side while it curves. The horizontal velocity does not change in any way while the football is being thrown. The y-axis increases a little and decreases because of gravity. The arrows slightly increase, then a bit after the arrows start decreasing, it shows that it has lost speed. The vectors start going upward at the beginning of the throw upon coming towards the halfway point, the highest point of its reach. The vectors get lower and lower while the ball is moving down. The vectors also go down into a negative point in the air. The gravitational force plays a part in the horizontal/vertical position of the ball, but air resistance is the main factor. Gravitational force is shown when I throw the ball, but without the air resistance, the ball would keep going higher and wouldn't come down for a long time.
Este video tiene como objetivo principal mostrar la fuerza y el movimiento de un objeto. Las fuerzas involucradas en este video son la fuerza gravitacional y la resistencia del aire y la fuerza humana. La fuerza gravitacional la podemos ver cuando la pelota está en el aire. La resistencia del aire vemos cuando la fuerza que sufre un cuerpo al moverse a través del aire, y en particular al componente de esa fuerza de la dirección de la velocidad relativa del cuerpo respecto al punto medio, cuando la pelota toma su punto más alto y después cae. Y por último, la fuerza humana es la inicial en este video para que las demás puedan llevarse a cabo. La fuerza net es un concepto que nos muestra la fuerza resultante que actúa sobre un cuerpo. La fuerza net se encuentra al considerar todas las fuerzas individuales que están actuando sobre dicho cuerpo. Estas fuerzas se deben sumar y restar para obtener el resultado final. Nuestros Y en X-axis nos muestran los cambios en nuestra velocidad y aceleración. Nuestro ejemplo nos muestra cómo todo lo que sube tiene que bajar. Por ejemplo, nuestra pelota cada vez que sube tiene una diferente aceleración, y así misma vez cuando baja. Por ejemplo, nuestra velocidad inicial comienza en 257.59 y nuestra X en Y son medidas en segundos, la que pudimos notar a la misma vez que nuestra velocidad sube y llega a un punto máximo y baja. Nuestra aceleración en este punto alto y baja a un punto más reducido.
Some of the forces that are involved during this activity are gravitational force and air resistance. We say gravitational force because it is always acting upon you. Now, air resistance is because of the hand movement. The net force is the final product between force and air force too. The way the net force influences the horizontal position in Brayson's legs is movement. When Brayson is in one position without movement, his legs net force is 0. But when he jumps and moves his legs apart, there's acceleration. His legs accelerate from point A by 1 meters per second, and they get halfway. When they get halfway, they start to decelerate. We notice this position by seeing that the arrows point to the left, but then it starts pointing to the bottom. How net force influenced the velocity to find the horizontal position is when Brayson moved his legs, and there was a constant velocity until the midpoint where it started to decelerate. The constant speed is so short that we don't really get to see, but it's there. This also happens in his arms when they move up. Same thing, just different directions and different forces acting on the legs and arms. We notice the velocity arrows are both in different directions, pointing towards the right and the left. The way the net force influences the horizontal acceleration is because both feet are at 0 meters per second. But after the acceleration starts increasing at 1 meters per second, but then after it hits 2 meters per second, it starts decreasing in the acceleration, getting to 0 meters per second again. Notice how the net force influences the vertical acceleration is basically the same due to both arms starting at 0 meters per second, then accelerating its way to 1 meter per second, then reaching its top acceleration of 2. Halfway, the acceleration starts to decrease, causing it to be at 0 at the top. We notice that the arrows of acceleration are all pointing different directions, being up, down, left, and right.
Thank you. That was our physics project for Group 9.